Right now, as you're hearing my voice, 3 pounds of soft tissue inside your skull is processing the sound, making sense of the words, and deciding what you think about it all. That intricate, powerful machine is your brain. For the next 4 minutes, let's take a look under the hood to see how it actually works. The whole show runs on tiny cells called neurons, about 86 billion of them. Think of them as the brain's messengers. They communicate using a brilliant two-part system: electricity and chemicals. An electrical signal, an action potential, zips down the length of one neuron. When it reaches the end, it doesn't just jump to the next one. Instead, it triggers a release of chemical messengers across a microscopic gap called a synapse. It's like a chemical whisper passing from one cell to the next. This happens across 100 trillion connections, all firing in complex networks, all the time, creating every thought, feeling, and action. So where do memories fit in? A memory isn't a single file stored in one location, it's a pattern. When you experience something new, the smell of rain on hot pavement, the face of a friend, a specific cluster of neurons fires together. To recall that memory, your brain lights up that exact same network again. And here's the amazing part. The more you recall it, the stronger those connections physically become. The pathways get thicker, more efficient. This is why practicing a new skill, or even just replaying a memory in your mind, literally wires it into your brain, making it easier to access next time. Of course, our brains aren't just for remembering, they're for feeling. Emotions often feel like they come out of nowhere, but they have a clear origin. Imagine a loud, sudden bang. Almost instantly, a small almond-shaped structure called the amygdala fires up. This is your brain's primal alarm system, producing fear before you've even had a chance to consciously process what happened. It's fast and built for survival. But a split second later, the rational part of your brain, the prefrontal cortex, catches up. It analyzes the situation and can send a signal to calm the amygdala down, essentially saying, "It's okay, it was just a car backfiring, we're safe." And when we shut down for the day, the brain's work is far from over. During the dream phase of sleep, called REM sleep, your brain becomes nearly as active as when you're awake, even though your body is temporarily paralyzed. One of the leading theories for why we dream is that the brain is performing essential maintenance. It's like a librarian for your memories, sorting through the day's experiences. It strengthens the important neural connections, the useful memories, and prunes away the clutter. And what we experience as dreams might just be the subjective, inside view of that incredible sorting process. All of this, neurons, memories, emotions, comes together when you have to make a choice. Every decision you make is a blend of cold logic and raw feeling. Your prefrontal cortex acts as the CEO, weighing the pros and cons, but it's constantly getting input from the emotional amygdala and your library of past experiences stored in the hippocampus. That's why a gut feeling is rarely random. It's often your brain performing lightning-fast pattern recognition, drawing on a lifetime of data to tell you whether a situation feels right or wrong long before you can articulate why. So, from the electric spark of a single neuron to the complex gut feeling behind a life-altering decision, it's all happening in the same 3 pounds of tissue. It's sorting your past, processing your present, and preparing for your future right now as this sentence ends. That's your brain. Thanks for listening.